And we're live. Can you hear me when I speak now? Tarja, Stefan. Okay, so I guess someone jumped off the stream, but that's okay. I was a little late. Some streaming issues here, but that's just to be expected. This is not what I do all the time. But we're here. So I'll start. This is ABCs of IAC. So we'll be getting into the technical stuff soon, but I will just start with some code of conduct stuff. This is Constable Bastian from Cardamom Town. He has made the Cardamom Law, and I kind of modeled the first one there after the Cardamom Law. So just be kind and be nice to each other. Show respect to people. Listen to understand, not necessarily to criticize. Be curious and open to share ideas and inclusive. And the last one there is very important. Don't be afraid to ask questions. I have also made another slide there. Please ask questions. We can all be better if people just ask. So this is the final message to please ask questions. There, who am I? So my name is Tor Ivar. I work for Soprasteria as a cloud engineer. Title is manager right now, but that doesn't really mean much other than level above senior. In the daily, I work with apps and infrastructure in Azure, and lately been doing more Terraform, Bicep, and previously did some Azure Resource Manager stuff, but that's kind of old days now. I'm also doing some governance with Azure policy, guardrails, policy-driven governance. I have worked with the cloud adoption framework, and I do some architecture stuff now and then. I'm also good at the problem-solving part, so that's kind of one of the things I do. Let's see, next slide. There. I was thinking I should start with the my journey, because I've had somewhat of an infrastructure as code journey from where I started. I started from school in a small application service provider in 2009 approximately, I guess, where I did on-premises stuff with data center planning, backup with System Center Data Protection Manager, Citrix management, deployment of Citrix, many other things, just kind of middleware stuff, Exchange. I did lots of on-premises stuff with assembling servers and switching out hard disks in a storage area network and all that stuff that you kind of start with. So there it was only ClickOps. Some Linux stuff where I could use Bash, but mostly ClickOps, just clicking around on the desktop there. Then in 2012, approximately, Microsoft decided to kind of end the Exchange Management Console. I tried the Exchange Administrative Console or Admin Center or what they called it, but couldn't be persuaded to use a web interface for managing Exchange, so I had to find something else. I ended up with starting to do lots of PowerShell from then on, because Exchange was my main area of expertise at that point. And yeah, started using PowerShell with the integrated service, the IAC integrated scripting environment in Windows. And I did that for a while, just getting used to scripting, getting used to using PowerShell and all of that. For a while, I did mostly that, and then the Azure thing started. I started with the Azure Classic stuff. Didn't have ARM templates back then, but then the Azure Resource Manager API came into be, and then I started with the ARM templates. So ARM templates, Jason, we'll get into that later. After that again, I used a lot of Azure PowerShell for deploying and managing Azure resources, Azure AD and all of that. That's like in 2017, I think. Yeah, I think we're at 2017 at that point. Used more and more PowerShell and more Azure PowerShell for managing all of this stuff. I remember creating virtual machines with PowerShell and yeah, doing loads of stuff with PowerShell there. And then we had the Azure CLI, the cross-platform command line interface that was kind of awesome. That you got this dedicated client for Azure command line stuff. And then for a while I used that for deployments and management. I think maybe 2018, 2019 or something, somewhere around there. And then came Terraform. So I started with Terraform for like 2-3 years ago. And after that, I've been kind of doing Terraform on and off, creating some larger platforms, some smaller platforms here and there, kind of working with modules and working with all the stuff required for doing infrastructure as code on Terraform. So that's kind of my journey from very on-premises ClickOps, and then Terraform, and then later year it has been Bicep. And Bicep is very promising, and if you're kind of Azure native, Azure only, Bicep is most likely the way to go for like point deployments or point management. But if you have a larger platform, you would want the added benefits of using Terraform. But we'll get back to that. So we are kind of at somewhat of a crossroads now for many people. We have like the tasks I would call today tasks and maybe tomorrow tasks. And I will speak a little bit more about this right now. Today, I say today, but I haven't deployed a web server for ages. But today, we can call it today. You install a web server, Internet Information Services. It's on a virtual machine, maybe on premises in the cloud. I've deployed Internet Information Services web servers in the cloud a while ago. It's okay. You create the server. If you're on premises, you maybe use vCenter or something to create the server. I don't know. Maybe Hyper-V. Maybe it's local Hyper-V on some workgroup cluster or whatever. But you create the server one way or another. Maybe you need to create network interface card, maybe create disk, and afterwards maybe you need to install the operating system. That's fine and all, but mostly ClickOps there. Many people use vCenter and clicking in there. Maybe you're doing management directly on a host somewhere. So it's like point and click. And then afterwards, you need to install the web services part manually with ClickOps there also maybe, or manually with PowerShell. I don't know. So you get this. Clicking around in add roles and features, choosing all the stuff you want, choosing for .NET, for 7, and all of this. I remember doing this, and I remember trying to replicate it on several servers. It's not very Not very cool if you're doing this on several servers and want to do like clustering or something. Can be hard to replicate. It can be can take lots of time, and very prone to errors, very prone to just doing it kind of, let's see, doing it the hard way. So this is Terraform. I would say maybe tomorrow, the tomorrow task, or maybe today task for some. This is just infrastructure as code. You write the wanted infrastructure, you deploy it with Terraform, deploy applications with GitHub Actions. You can deploy the software, GitHub Actions. You can install Internet Information Services with PowerShell extension. You can store the passwords in a key vault. We'll get back to all of this later. I just want to show a little how this can be done in Terraform. So this is like call it the next generation or current generation infrastructure as code. But I will say, don't panic. We can get through it and we can get into infrastructure as code. So this is the good part. What is infrastructure as code? So VMware says that infrastructure as code is the practice of managing and provisioning infrastructure through software and automated processes rather than through hardware and manual processes. Software developers can write and execute instructions for compute, storage, and network requirements and provision them more quickly, blah, blah. So this is a good definition. You start doing infrastructure in the code instead of doing it with ClickOps or manually. You don't have to do the hardware stuff and kind of on demand. Red Hat's definition is kind of similar. Infrastructure as code is the managing and provisioning of infrastructure through code instead of through manual processes. Automating blah blah, don't need to manually provision servers and all that. So infrastructure as code is just managing your infrastructure and applications through code instead of manually. So that's the high-level explanation. There are advantages to doing infrastructure as code as opposed to doing ClickOps. I'll get into that now. Just checking for questions there. So, consistency. Infrastructure as code can improve consistency and reduce errors that happen during manual configuration. You can get a consistently good platform if you do things with code. You can consistently do resources that are similar. You can make sure that the naming standard is being upheld. You can be consistent. You can version your code. So, and then by definition, version your infrastructure. So you can say that right now I'm at version 1 of my infrastructure, and tomorrow when I commit something to this repository, it will be version 1.2, 1.1, whatever. You can kind of point back and tell where you were on a particular point in time. You can get automatic documentation. So infrastructure as code can help you automatically update your documentation, which means you won't have this old documentation lying around anymore. It can be very efficient and nice if you do it correctly. Markdown, whatever, it can be sent to Confluence, it can be sent to SharePoint if you want that. So very good and automatic support for documentation there. You are set for repeatability. So if you do something in a dev environment and then you have to do it in a test environment and then you have to push it to a production environment, you can make sure that this is done the same way. You get possibility of using the same modules and just replacing the parameters. And then you won't have to handle that firewall opening any that you had in development stage. You have it in your code, and it's automatically provisioned to test when you need it there. The firewall rules are just as you had them in dev. Everything works like it should. Readability and reviews, or the 4 eyes principle, that's something I like here. You can read and you can see the code at a glance. Of course, if it's very complex, it's hard to see the overview in your mind, but you get at least some form of insight by looking at the code. And also with the reviews and the 4 eyes principle, you can have people looking through your changes before you actually do them. So maybe before you could sit and do stuff with ClickOps with someone sitting behind you and watching your clicks or clicking together with you. But with this, you write your changes into the code, and then you do what's called a pull request, and then you merge your changes into the production branch. We'll get back to these terminologies things later. And then someone can look at your changes and they can say, oh, he did a good job here, so I'll approve it. Or they can say, this is not good. We need to change this, and this would destroy production, and this would give a security vulnerability or something. And that's great, I think. Then you get the speed, because when you have the repeatability, you can kind of scale, and you can repeat with speed. So you can deploy services at speed you maybe couldn't before. Since all of this is automated, you can also give it to developers so they can develop at speed. So this is kind of the good advantages of infrastructure as code. There are also more. You get risk reduction because you can do configuration files in source control. So you reduce risk in that way. You can get vulnerability checks for your configuration as code, and then get improved security at the more left in the cycle. You can get reduced cost because when you deploy stuff here, you always have an overview of what you have, and you can implement automatic cost calculators. You have these APIs you can talk to. InfraCost is one of them. So you can use Terraform, and then you can talk to InfraCost, and they can say, oh, this change would increase your costs $200,000 a month. Maybe not do that. And then you get efficiency here. If you get the templates and the moduling, you can get a very good provisioning system that can make you do things efficient. So that's maybe like speed, I don't know. Now, there aren't only benefits or advantages with infrastructure as code. There are some disadvantages. We'll get into them here. You have the competency or the skills gap. If you are going to do infrastructure as code, you need some new knowledge. You need to learn stuff. You need to maybe do GitOps. You need to learn GitHub. So there is a skills gap that needs to be filled. This is kind of a disadvantage, but on the other side, it can be an advantage for the people working at your company or for the employees, because then you are required to increase your skills, and then maybe you will have a better work life if you can stop doing the boring things and start doing the fun things. First deploy time will always be somewhat of a challenge, because the first time anyone needs to create something, it will take a little bit more time to find out, okay, how will we do this in code? But then you also can look at the internet and find templates everywhere. You can find quick starts for Azure. You can find, all of this. Very good, but it will take time the first time. So you have to do it, and you have to kind of know how to do it. Adoption is a challenge. IAC can be hard for some. Everything is hard in the beginning, I guess. But adoption can be a challenge here. the complexity of your environments can get hard to get an overview on. So if you have thousands of configuration files lying around, that will be complex to have an overview of. But if you have thousands of servers managed by ClickOps, that's also complex, I would say. But this is also a disadvantage of infrastructure as code. I said that I like the 4 eyes principle, but it can be kind of a nuisance if you want to do something in the weekend, or if you want to work overtime, or if you want to get stuff done outside of working hours, and no one can check your changes. So this can also be a disadvantage. ClickOps and DevOps, they can mix, but it won't always give you the won't always give you the great difficulties, but it will give you a headache when you have to reverse engineer stuff that's been done in ClickOps to try to fit into the code stuff. So these are the kind of overview disadvantages that I can think about. Anyone else has some? Oh, I think we're a little bit behind here. I'll just move along. So as I said, the infrastructure as code mindset adoption can be challenging. That's kind of just the way it is, I guess. It's can be hard. You can have employees or colleagues that have kind of are a little bit defensive because maybe they feel like the jobs are kind of going away. It requires the engineers to get out of their comfort zone. You have to do something you don't know, maybe. It most likely requires that you learn something new. And I guess that can be a challenge if you're not used to the mindset from before. So this kind of sets the stage to talk about the basic terminology here. Let's see. Yeah. So the basic terms. We have some terms here. Git. That will be a term that you will hear often. It's a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. That's what you can read on the Git page, where they explain themselves what it is. So when we talk about Git, we have to talk about some other small terms also. You have branches. Branches are kind of like your code in a kind of copy that you can do changes to, and then you can make different copies in branches with feature updates or new servers or new security features or whatever. So branches is a kind of a term you need to know. You do some staging on your client before you commit, as they call it, to Git. And that just means that you save your file that you're working on, then you stage it to kind of prepare Git for receiving it. Then you commit it to your Git locally, and then you push it to the remote repository. And then you can have a pull request, which is kind of a confusing name because what you want is it's kind of like a merge request. You want to send your changes into the main branch or the trunk. And this is also a term that's nice to know, pull request. It will be something that you have to do if you're doing infrastructure as code with a team. You have to know about this. Pull request reviews, that's what I talked about, readability and reviews and the 4 eyes principle stuff. That's mostly done with pull request review process. Repositories, just storage containers for your code. It's as simple as that. You store your code locally, then you use Git and make a repository, and then you send your code to a repository somewhere else. So you can have remote repositories and you can have repositories on your client. It's just a place you have your code. CICD, it stands for continuous integration, continuous deployment. So it's a method to deliver applications and to do kind of continuous updates of them. You build and release and all of that. It has a few meanings though. The CI always refers to continuous integration, which is this automation for developers. The CD can refer to continuous delivery or continuous deployment. So this means that the code is built and kind of maintained in a repository, and then the deployment part is when you push your infrastructure into the cloud or wherever. Workflows and pipelines, this is the automation part. So this is the part where you kind of deploy things. You have GitHub Actions, and then you have Azure DevOps pipelines, or GitHub Workflows, or GitHub Actions. It's kind of the same term. Collection of tasks. So you have SRE, which is Site Reliability Engineering. It's just some principles and practices to do software engineering, and apply them to infrastructure and operations problems. So scalability and reliability is kind of a focus for an SRE, which is kind of a site reliability engineer. Azure DevOps, that's kind of a bad name for it. It's not Azure and it's not DevOps. It's kind of a tool set from Microsoft to replace the Team Foundation services, or the on-premises stuff that we had before to do kind of pipelining and repositories and all of that. So Azure DevOps is the Microsoft way of doing repositories and pipelines and all of that. Now they also bought GitHub and then did some stuff, and now GitHub is kind of also good. So I like GitHub the most when I work with this, but GitHub is the next term here that you need to know. GitHub it's just a different productification of Git. So you'll get Git as a service. You can use GitHub, you can use Bitbucket. There are several others also, but I haven't really looked into them as much. But they will give you a repository and some pipelining and workflows and all of that to deploy your code. GitLab, that is a local version of Git. So you can host GitLab by yourself, or you can buy GitLab as a service somewhere else. It's a good way to kind of inner source your code and your pipelines or your runners and all of this that is required to do the CICD. The term IAC stands for Infrastructure as Code, which is different from IaaS, which is Infrastructure as a Service. You also have Platform as a Service and Software as a Service, but that's a whole different discussion. But it's not the same. And then you have someone is using the IaaC and says Infrastructure as a Code. That's so maybe someone says it, but the IAC kind of is the standard way of saying it. So I guess this this is not like thing here. It's just because I don't like when it's written IaaC somewhere, because I find it confusing. It's kind of confuses it with some other terms. DevOps is the automation way of doing it. ClickOps is the portal way of doing it, or the Windows desktop way of doing it. IDE and ISE, that's just some short for integrated scripting environment. If you remember the PowerShell ISE, I used that for a while, but now I've gone over to the VS Code, the Visual Studio Code editor. And Visual Studio Code, Visual Studio, PyCharm, you develop applications or other types of code in there. So any terms that you know that you haven't heard here yet? I'll just keep looking in the chat and see if there are some questions there, and then I will kind of collect the questions and do them in the end. So just write the questions in the chat if you get them. Now, these are also some important terms. Idempotency. That means that no matter how many times you run your infrastructure as code and what your starting state is, you will end up with the same end state. It simplifies the provisioning of infrastructure and reduces the chances of inconsistent results. So this is an example that I found somewhere on non-idempotent versus idempotent. You can see in the first, in the left side, the VMs are provisioned, and then when you reapply the code, they are re-provisioned as new virtual machines. This is not what you want. You can get this if you have a PowerShell script that creates VMs based on a random string, and then that random string hasn't been controlled in some way. Then you get one set of VMs, and then when you reapply, you get a new set of VMs. So you expect it to be 3, but it's actually 6. When it's idempotent, you provision them, and then the provisioner will understand that you are not creating new VMs, you're just reapplying the old ones. So you won't get 3 new VMs, but you will kind of get the idea or get the message that your infrastructure is as it should be. No changes needed. That's what Terraform would say anyway. Mutable versus immutable, or the pets versus cattle discussion. So immutable infrastructure means that instead of changing an existing infrastructure, you replace it with something new. So if you deploy a server, instead of updating it, you would kind of deploy a new server with the updates and get rid of the old one. Mutable means that after the resource is created, updates are done like in an ad hoc basis, and this causes configuration drift and what you could call snowflake servers. So snowflake servers are the kind of special servers that you can't touch because no one knows how they work, and the guy that handled them, he kind of quit some years ago, so you can't be you're scared of updating it. This is a snowflake server. So the pets versus cattle is that if you treat your resources like pets, then you will be dependent on them, and then you will get problems if you have to kind of remove them. Okay. So pets versus cattle, yeah, if you have cattle, you just kind of replace the ox with a new ox, like. So here we have mutable infrastructure in the left. You deploy them and then you update them with when unapply changes. And in the immutable infrastructure, the part that you can't see down here is it says it provisions new infrastructure with v2. So you deploy the servers, and then when you need to change them, you redeploy new servers with v2, and then the users are pointed to this one. So that's the immutable part. It's kind of like updating versus not updating the resources. Declarative versus imperative. This is kind of an important point also. Imperative means giving instructions on how to create it in addition to what needs creation. And the declarative method means giving instructions on what to create, but not how to create it. So I will do an imperative demo if I can. Let's see. I will get these opened. This is my Windows terminal. Oh, it's slow now. My computer is struggling with streaming this. Yeah, 9 seconds. So these are my demos. So PowerShell first. PowerShell is the imperative option. Here it will tell how to deploy stuff, and it will also tell what needs to be deployed. Let's see, open with code. So this is the script. You can see that it is the resource group is created first, then the virtual network is created, then a subnet, then the virtual machine. So if I move this VM stuff to the front, it wouldn't work. Then it wouldn't understand what to do. So this is the imperative method of doing things. If I run it here now, it will kind of work, I think, if I'm logged on. This will be slow anyway. Yeah, no, not happening today. Anyway, this is the imperative way with script. So it's dependent on the order of deployment. If you were to do it the Terraform way, the order is not important. It will do the dependency mapping for you. You will get all of this handled. So this is Terraform code. It is declarative, which means that I am telling Terraform what I want Terraform to create and not how I want it to be created. I just say this is how it's supposed to look later. So if I do Terraform plan, it will tell me how things are right now. So I will get, okay, so this isn't going to work now either, I guess. Let's see what task manager says. Yeah, of course, Windows Defender also decided to join in. So this Terraform plan will tell you. Okay. I need to get a new computer or something. Okay, I'll close this one and then maybe it will get back, I hope. Let's see what happens here. Okay, I think maybe we're back again now. I'll try to start again. It's just my computer is kind of struggling to keep up with the sending the data. So languages, frameworks. ARM templates, they are kind of painful to look at. They are the old way of doing things, old way. Many are using ARM templates also now. You have JSON syntax, it's kind of difficult to author and read, and there is challenges with nesting and linking. This is not a deep dive into any of these languages, so I'll just kind of move past them quickly. Bicep is the new ARM templates. You get Azure-only stuff. You get good syntax. You get better modularity. It's easier to author and read. Looks like HashiCorp configuration language, so Terraform, and it compiles and decompiles. So Bicep is a very good option right now. If you're starting out with Azure infrastructure as code, I would very much recommend starting with Bicep and kind of just look at ARM and see what it is, but not learn it deep dive. Terraform is by HashiCorp. It's the language is called HCL, so HashiCorp Configuration Language. It is declarative. It's multi-cloud. It's provider-based, which means that you can use Azure, AWS, GCP, Oracle Cloud Infrastructure. You can also order pizza and manage your playlists with Terraform. So it's a great and big tool that you can use for many things. Pulumi is like the real infrastructure as code because this is actually programming languages. You can use .NET Core, Python, Node.js, Go, or Java. It is also declarative like Terraform and Bicep, and it is multi-cloud. So you can use it with different providers, and it's I guess it's great for those that are using it. I heard LCHUP is using it to deploy stuff and have done some self-service stuff there. Others, honorable mentions, AWS Cloud Formation, that is AWS specific infrastructure as code language. You can use Ansible or Chef or Puppet, but in my mind, they are more like configuration as code as opposed to infrastructure as code. So you may want to separate those. You can use Terraform for your infrastructure, and then you can use Ansible, Chef, or Puppet for your configuration. So installing Internet Information Services with Ansible, Chef, or Puppet, or disaster configuration, or whatever. Just it's okay to separate the configuration of the servers into a different language than the creation of the servers or the resources. So this is the CICD pipeline. You commit the change. This triggers a build, and this build will build your application or build your end state. It will notify of the outcome. It will run some tests like checkoff or something. It can run linting and all of that. You will be notified of test outcome, and then the build will be delivered to a new kind of job that will deploy your resources or your application where necessary. So in Azure DevOps, these are called pipelines. In GitHub, these are called workflows or actions. And this is also great to know. Azure DevOps pipelines is kind of the way of deploying resources from Azure DevOps, and GitHub Actions is the way of doing this from GitHub. So my generic workflow when working with Git is just pull the main branch or the trunk, so you have the updated version on your client, and then when you have the updated version, you branch out to do whatever you want to do, give the branch a meaningful name. You develop in this branch locally on your computer or your client, and then when you're ready to merge these changes with the trunk or the main branch, you would do a pull request. And then when this pull request is reviewed and found okay by another person, you can get this merged into main, and then this will be deployed to production. So this is the kind of the generic workflow for everything. Maybe the last part, the pull request and the review, you can drop that if you're doing something on your own in a different project somewhere. But it's great to kind of get to know the way of doing things in a team, because if you are in a team, you will want to follow the pull request and review track. So when I'm doing Terraform, you always have to have the git ignore that goes with Terraform. So git ignore is the file for GitHub repositories. If you make this .gitignore file, it's a hidden file. If you make this in your repository, GitHub will ignore certain files. This might also be for other Git versions. I'm not sure. I've mostly been using GitHub. But this is at least the case for GitHub, that the gitignore will ignore local files that you put in the gitignore file. I like to use pre-commit hooks, which means that before I commit something to my local Git, it will be checked for linting errors, it will be checked for spelling, it will be checked for validation. So it does some Terraform validation for me before I actually send it to Git locally. And then I kind of can get rid of the syntax errors and all of that validation stuff before this even goes to Git. You can do some local plan stuff if you want. That's up to you. I do it if I can, but it's okay to kind of see the plan before you send it off. Most times the plan part of the Terraform plan will come when you do a pull request. So Terraform plan will show you a list of the changes that needs to be done with your infrastructure in Azure or AWS or wherever to make this look like your code. So the Terraform plan will show you a step-by-step plan for how this infrastructure will be deployed. Then you do a merge. This will get together with the main branch, and when you merge it with the main branch, most likely it will be applied to production and your infrastructure will be created. This is the way I prefer to do it. So a pull request will trigger a plan, which then comments the plan to your pull request in GitHub, and then merge will apply stuff. Bicep is a little simpler. You don't need the plan part because there is no plan part. Bicep has the what if that gets put in the pull request bulk. Before that, you can do a build, a test, or a lint. I guess there will be some more tools for this when Bicep matures a little, but for now we have the build, which will compile a Bicep file from a JSON file. Or it will compile a JSON file from a Bicep file. At least it compiles something and tests it at the same time. Then you can do some validation, and then the pull request can do what if. What if in an ARM template and the Bicep template is just kind of checking what you have, checking the status of your infrastructure, and letting you know what needs to be done for it to be like you want. And then the merge will, of course, deploy the infrastructure to production. I am not sure we have time for the tooling. I can go through the tooling. I use Windows 10 at the moment because I have a Superstea computer and I need to use some tools that are only available if I have this connected to Intune and all of that. So I haven't been checking very much if I can go to Windows 11 because I have Windows 11 on my other desktop, but at the moment Windows 10 is working okay for me. You need to have Visual Studio Code. Visual Studio Code is my favorite code editor. It has lots of extensions. You can see in this is my Visual Studio Code, and you can see that it is. I'll start a new VS Code so you can see that. These are the extensions, and then you can see there are some extensions here. You have Azure CLI tools, the ARM tools, the Bicep, some Docker, which makes it easier to manage and create debug containers. I have my theme here, Git graph, to kind of get a graph of your Git branches and trunks and all of that. Git history, I have Git lens, I have the Terraform extension, the Markdown all-in-one to get some Markdown stuff. the markdown lint to kind of lint the markdown before it is sent to GitHub or wherever, so I can get lines under the things that are wrong. Paste image is a great extension. If you paste lots of images from the clipboard into your markdown, it will kind of store your image in a folder and it will link to it in your markdown. So that's very great to simplify pasting of the image. Of course, I have the PowerShell extension to manage PowerShell scripts in Visual Studio Code. It's great. Remote containers and remote WSL. That is great for working in a container locally on your computer, on your Windows. The to-do tree is something I found that when you write something to do in your code, you will get this in your to-do tree. VS Code icons, that will make your icons pop. So you can see the cool icons here. Kind of just a GUI thing, but it's okay. And then YAML to kind of get a color syntax on the YAML files that I do. I do some Kubernetes manifests and all of that. So yeah, there you have it. That's my extensions. I also have enabled the settings sync. So the settings are synchronized up to GitHub with my user. And if I open Visual Studio Code and log in somewhere else, it will download the settings for me, or it will ask if I want to reset the settings. So this is great for if you have several computers where you do stuff and want the settings to synchronize across them. Windows Terminal. I don't think I want to start it now because I think maybe the stream will freeze again. But the Windows Terminal is great for doing PowerShell, CMD, WSL, all of that. It's great stuff. So if you don't have Windows Terminal, I would suggest install it. And also with it, you should install the new PowerShell core, which is not new anymore, but the PowerShell core 7.2.4, I think, is the latest version now. Use it. It is cross-platform, so you can use it on Linux, Windows, and Mac. You can use it wherever you want. By the way, I also saw Visual Studio Code installed on an Apple Watch the other day. So that's cool. Maybe not very necessary, but cool. You need to do the WSL if you want Linux in Windows. The WSL2 is with a real Linux kernel, and you will be able to do more stuff with it. It's great for doing Linux stuff. And for my part, I don't want to use Linux on my desktop because I like the simple Windows life. And with WSL2, I can do the Linux when I want to, like open SSH to do some key generation or do SSH connections somewhere. Yeah, whatever. That's also supported in Windows now, though. But yeah, Git for Windows is absolutely necessary. You need that to work with Git, so I would just install that immediately if you're using infrastructure as code. GitHub Desktop, if you are using desktop, using GitHub, you can get a GUI for your GitHub stuff. It can simplify things if you want to do it with a graphical interface. Also, the Visual Studio Code, it has good Git extensions which enables you to actually do lots of Git stuff directly from the portal or from the editor with a right click or clicking and choose push or synchronize, all of that. Screenshot software, I use Screenshot. It's great for taking screenshots, and I like it very much. Docker Desktop, I used this one before, but then Docker Desktop got a new license, and since my company has more than this and this amount of employees, I'm not allowed to use this anymore. So I kind of had to remove it. But it can be nice if you're playing around with Docker on a private computer. It is really simple to use, and it can use WSL2 as a backend, so you don't need to have Hyper-V or anything installed. It will just use WSL2. There are many good guides on this on the internet. Visio stencils. You can Google Sandro Pereira or David Summers and get their Azure stencil pack or integration stencil packs. They are great for getting the good diagrams in Visio if you have access to it. You can also do many other online stuff. So just Google some diagrams. I think brainboard.co or they have something. And you can use diagram.net, I think it is called now. It's the old draw.io. It's a cloud service where you can draw diagrams. It's great to use. It has Azure symbols and it can export to PNG and all that. It's great. The AZ predictor is really great to use. It will try to predict what you want to do based on your history, and you can get suggestions. Azure Storage Explorer, I don't use that as much, but it's good to know that it's there. Yeah, Podman can be a replacement for Docker Desktop, I guess. I haven't looked into it because I haven't been working as much with Kubernetes and all that as I've needed to the last period. So I will definitely look into Podman when I have the chance. So I will open the floor for questions. There haven't been much yet, as far as I can see. No. This is about the last, it's soon the last slide. So if there are no questions, we can kind of just wrap it up, I think. Yeah. Not any questions as far as I can see. I need to market these meetups a bit better, I think. So, thank you for your time. Connect on LinkedIn if you want. You can connect with me and ask me questions if you want. That's okay. Follow me on Twitter, and sometimes I post things, sometimes I don't post things. I have a GitHub you can check into, and in there you will find the Trondheim Azure community repository where I will also share some slides and all of that. And please, if you liked it, tell someone. If you didn't like it, tell me. You can do the star review for Meetup. I think you will get a reminder to do some feedback. I haven't really gotten any feedback on any of the other meetups, so I kind of don't expect it, but I would appreciate it if someone would say that it's an okay use of my time. So with that, I think maybe I'm done. And thank you for watching. Bye.